then what? And test, and we deploy the deployment, and then implementation starts. Okay, don't ever forget this. So this is the implementation. So it goes on and on. This is why this process is called software development lifecycle. Actually, it's not only software, but probably you can apply this approach or this cycle to any kind of developments, but specifically we're talking about software development. Therefore, this is the software development life cycle. We need to, or system development life cycle, we need to keep it in mind always. As I mentioned earlier, there are two main principal approaches to this development cycle. One is called the waterfall method. Waterfall method. Using waterfall method, we complete every stage one by one, just like a waterfall, right? Waterfall. This stage is complete, and then this stage goes. So assume that water falls down. So this is called waterfall method. Şelale metodu. Of course, it is not that strict. It's not a good analogy because here you cannot take the water back to this stage, right? In the reverse order. But here you just go back and forth many times. This is why we draw these intersections. Just to remind you, these are the principal points in this software or system development. Therefore, in waterfall method, we complete this stage, then go into this stage, and the main goal, the main expectation actually, is to complete this stage or that stage, every stage, as it is supposed to be. I mean, we need to cover all the required processings and everything, and all the forms are developed, blah blah. Then we go to the next stage. Doesn't mean that we cannot go back, but it's the principle. Complete this and this because the logical rationale behind it is very simple. I mean, if you move forward without completing truly, for instance, design stage, and go develop system and test, and then at the deployment stage, or maybe during the implementation stage, you realize that you designed something incorrectly, you need to go all the way back. So it has obviously very burdensome. I mean, it has some real difficulties, causes a lot of time and money, effort, etc. So the rationale behind it, complete every stage as it is supposed to be, truly do what it requires completely, truly, then decide to move forward. And actually, during these decisions of moving forward, user involvement is also required. I mean, you just present your report, not maybe the whole technical details of your design and everything, but the principles to the user, right? The user of the system. So you review the stage, let's say stage report at the end, and agree upon the, let's say if it is design, agree upon the design. Then you decide with the user involvement, you decide to move to the next development stage or test stage or whatever, right? So this is the waterfall methods philosophy. But in agile systems, aranızda who are taking that agile course? Agile 1, 2, only 2. Pity. Agile method is the other method. It approaches the whole thing in a different way. It says that throughout all these processes, all these cycles, you keep the user as in the system, in the decisions, every step, as much as you can. Okay? So they always develop something. For instance, until this point, we do not write any code, right? No coding, nothing. But in the agile system, we code here and there and there and there, continuously coding, coding, coding. But all the modules and everything are empty, just to give an opinion what's going to be when this system is completed, what's going to look like, and get the user's opinion and idea, correct it, modify it, refine it, step by step, gradually. Okay, because the philosophy is very simple and understandable actually. They say that the user cannot see the problems and describe them as you expect them to describe, or they cannot understand your design or technical base anything, but you need to approve and you need their approvals, right? They are the authority to approve it. Therefore, without them, you cannot decide anything. But this way, if you have some misunderstanding, developing something incorrectly, at any stage you can realize it by the involvement of the user and go back and correct it and continue, right? So agile system is a little bit different. It requires lots of continuous meetings with the user, again and again. Maybe every 1 week or 2 weeks, you get together with the users and discuss about the current status, current development of the system, etc., and write reports, everything. But that doesn't mean that if you're using agile system, we just omit the analysis or the design. The required processes you need to do during design, for instance, or testing or whatever. You do the same things, right? But the approach is different, philosophy is different. Therefore, I believe that for two of you, what was the name? Erkan Sarıkaya. Will teach you all the details and everything. But for this course, I just mentioned it and gave him the idea what kind of approach it is. Then we'll continue. From my experience, I can tell you that neither this waterfall nor agile works. We need both of them. We implement both of them, apply both methods, right? Because both questions or let's say advantages are correct and real. This question is very real. I mean, if you make a mistake and realize it in a later stages, you need to go back all the way and then start over from maybe analysis and design. So, as I said, it's very, very burdensome. It's very difficult and it costs a lot. Therefore, you need to get the user involved and approved as much as you can. So it's somehow agile. But only agile wouldn't work, because during the agile method, user may say that, okay, it looks great, continue. Then you may omit some of the things that you need to do. And then later on, during the later stages, they may realize, the user side, realize that, but there should be some feature like this or that, or we cannot handle this that way as you present, then you need to go back. So you cannot trust the user completely, because they do not know how to solve the system, right? They know the problem. They know the problem. So again, here is the user having the problem. Okay, and we are here, the tech people. We have the solution, right? We need to create this bridge, and this bridge is built only through the systems analysis, not design, but analysis. Okay? So that analysis stage is very important. We are about to get into this stage. Maybe today we'll start talking about it. This is probably Now, every stage is of course important. Every step is important, but this stage is the stage that takes the longest time. Actually, it's supposed to be that way. Again, as I draw a timeline, if this is the initiation stage, which includes the preliminary the analysis and design, right? So it should take some time. Then analysis, then design, right? You can compare this way. And coding maybe as much as that stage, coding or development. Then test, which is almost as long as that coding stage. After coding, deploy is nothing. We just deploy and go back, okay? This is the implementation. So here is the maintenance. It goes back to that point. So what I'm saying is analysis takes the most of the time, which is supposed to be that way. Why? Very obvious. You need to understand what the problem is, because you cannot give a correct answer to an incorrect question, okay? You need to understand the question, right? And it is not that easy for us as technical people to understand what the problem is, truly, because it can be originated from any sector, maybe textile, maybe food business, anything. You see, even if you develop some, let's say, warehousing systems, some automations in production management of this type of, but the sector is different. So everything may be different. Even if you're working in the same sector and same application, let's say that you're working on a warehousing or stock system, something like that, the main problem, in definition at least, is the similar. The same. Like if we're talking about a stock system, the main problem is we need to keep track of all the goods, incoming goods and outgoing goods, and we need to keep them in place and deliver them in time, right? This is the main problem for every warehouse. And believe me, I developed too many warehouse systems, but none of them were the same. None of them were the same, even if they were from the same sector, right? All have their very peculiar and different problems, depending on the company. The culture of the company may be different, and everything may differ. Of course, they have some common parts. Of course, in all warehousing systems, you're trying to solve the same principal problem. There are the details. And, I don't know whether I say in English that saying, but devil hides in the details. Türkçe'de var böyle bir şey. Değil mi? Devil hides in the details. There is no such a saying. Değil mi? O devil comes and finds you somehow. Dolayısıyla arkadaşlar, I can tell you that this is the most difficult from outside. Most difficult part, because we're dealing with something we do not know. We're total strangers, right? And we have to learn everything, the problem, better than them. Very interesting, because they are in that problem, living with it, right? So they somehow got accustomed to that problem. That causes them not to be able to realize or describe it to the content. Because very accustomed to that problem. Okay? Just like assume that some lamp burada mesela pırpır ediyor, malfunction. Şimdi bir gün farkına varıyorsunuz, ikinci gün falan, ama sürekli buradaysanız bir süre sonra ona adapte oluyorsunuz. Dolayısıyla buraya geldiğinde hani birisi ne problem var, sandalye masa şöyle falan diyorsunuz, onu unutmuş oluyorsunuz. Yani o hayatın bir parçası haline geliyor falan. Dolayısıyla siz dediğim gibi total strangers and you expect them to describe everything, the problem, the details and everything, but they're not completely compatible. Although they're experts on this subject, this area, whatever they're dealing with, they're not completely able to describe every detail and everything, because it is very obvious and common from their side, you see? Very obvious and common. For instance, let's assume that you wrote a program, and that program asks the user for entering his student number, for instance. Would you need to tell the user or somebody that you need to write or hit the key, number keys on the keyboard, right? Do you need it? No, because you think that it's obvious, right? It's asking about your user student number. Nobody writes the Ahmet, Mehmet. You're expecting to enter some numbers, right? So you never describe it, or you just omit. It's so natural, but it's not so. If you're writing a program, you have to think about it. I mean, all the programs, all the software are supposed to be written for stupid people, the dumbest people. You may think that nobody enters his name to student number, but they do. They always do. So you are the one to take the cautions and all the precautions and everything, okay? Controls and everything. This is why we say that if you want to learn something, read it, study it, etc. Remember that saying? If you want to really need and understand and comprehend it correctly, truly, you need to teach it, tell it. Because during that process, teaching or telling process, you realize that the missing points you realize. You will understand that, oh, I missed that point, I'm not very good on that point. All right, you realize that what points you missed. So you go back and recover it, okay. But if you want to be a master of it, what should you do? What does it? Programs, write programs. Okay, write programs. Because during writing a program, you need to think about all the details, all the stupid, dumbest details. You have to think about and take controls and everything. Okay. So, if you take it this way, it is so natural. Most people cannot describe the problem completely, truly. Instead, you need to go there and ask them and observe it. Okay. So there are methods for this, but none of these methods are complete, or there is no magical method or something. Apply this method, it's solved. You understand it completely. There is no such a way. You need to be very careful. Besides, there are some things that some of the textbooks never cover or mention. There is something called user resistance. Ever heard of it? User resistance. It is a reality. It really exists. Some of the users do not want that system to be developed because there may be their own reasons. I mean, he is about to get retired, for instance, and he doesn't want to learn a new system or something because he is the expert. Everybody consults him. He's the oldest guy or oldest employee, let's say. Everybody comes and consults him. Where is that thing? How can I find this? So he's the valuable one, right? But if you replace him with a new system, it won't be very good for him, right? So he may resist. And user resistance is not something that always takes some naive, acceptable forms. It may be very harsh. I lived through such things.
Or sometimes, like some operating system not developing for the maybe average members. For example, Linux operating system. Not everyone can use Sytem because it's developing for the professional and can be different sometimes, right?
Yeah, I understand, but I'm not talking about the user friendliness here. Of course, the system should be user friendly, and even the dumbest person can use it, right? But what I'm saying is, as the programmers, you need to take all these possibilities into account. Okay, if there is a text box saying that enter your student number, you should think that he may enter some alphanumeric values or something. So you need to put some control. It wouldn't hurt user friendliness. It is a requirement. I mean, you have to take some action when he enters some alphanumeric values. You need to take action. So for the sake of user friendliness, you cannot accept whatever he enters. It's another thing. User friendly is another thing. Alright. Mesela arkadaşlar sistem kuruyoruz, kurduk. Haberi sıkıntı geliyor. Yani işte çalışmıyor sistem. Bir de enteresan olan böyle. Size böyle oluyor demiş. Ya sizin sistem çalışmıyor. Yani gördüğüm en uç örneklerden biri olduğu için söylüyorum. Gidiyoruz, bakıyoruz, evet çalışmıyor sistem. Ama gidiyoruz, bakıyoruz ki bildiğimiz kablolar, data kabloları kesilmiş. Kesilmiş yani. Yani bu user resistance oralara kadar. Tamam mı? Bu bir belediyeye yaptığımız bir işte şeydi, böyle geçiş kontrol, bilmem ne, şehirler arası terminalinde onlar bakıyorlar oraya. İşte gelen bütün araçlar oradan yakalanıyor, takip ediliyor, bariyer kalkıyor falan. Böyle bir sistem. Dolayısıyla kim geldi, kim gitti, oraya belediyeye o şeyi, terminali kullandığı için o otobüsler bilmem ne para ödüyorlar. Belli bir para ödüyorlar. Belediye de bunun takibini istiyor. Ama sistemden önce, yani sistemin kuruluşundan önce, kurulmadan önceki hal nedir? Orada kulübeler var, kulübede görevliler var. Görevliler geliyorlar, işte kaç para? 50 lira, 100 lira, 500 lira neyse uzatıyor işte şoför, otobüs neyse, kamyon değil, otobüs falan böyle şey. Adam da basıyor, işte şeyi açıyor, şeyi giriyor veya işte yakalıyor falan, ki giriyorsa giriyor. Böyle işliyor. Adam 10 tane araba geliyorsa 3'ünü alıyor. 2'sini alıyor. 5'ini cebine indiriyor. Böyle yürüyor diye. İşte. Şoförle kırışıyor. Şimdi adam seninle bunu paylaşmak istemiyor. Ya da böyle bir sistem olsun istemiyor. Yani iş buralara kadar varabiliyor yani. Veya yine Çukurova'nın bu Caterpillar falan şeyleri var ya, işte oraya yaptığımız projede bir tane adamcağız vardı. Adamın ağzından laf almak mümkün değil ya, hiçbir şey anlamıyor. Seni yanlış yönlendiriyor, en uç örnekler. Dolayısıyla as I said, that there is no magical method or something that ensures you that you can get all the information you need about the problem, etc., the workflow, the business. It requires some personal skills, actually. Your communication skills is very important. Gittiğin zaman oradaki insanlarla ilişki kurabileceksin. Abi diyeceksin, nasıl gidiyor falan. Yani onu da birazcık hakikaten göstermelik falan değil yani. Hani hakikaten o duyguyla gideceğim. Onlara da yarasın falan gidiyor. Yani o iletişim yetenekleri orada çok önem kazanmaya başlar. Şimdi biz aslında çaktırmadan baya gittik sistem analizi. Aslında sistem analizi ne demek ki? The most important point in the systems analysis, as I said, every stage has its own requirements. Right? For instance, during this stage, we need to complete this and that and that. Okay, these are the outcomes of this stage. All right? So these are the requirements of this stage. Somehow, these are the required points or outcomes that you need to complete, get it ready. Right? So I can call them requirements. For this analysis stage, the most important outcome or the requirement for this stage is the requirement analysis itself. Okay? Requirement analysis. We call it requirement analysis. It is the key of everything. All right? It is the key of everything. What requirements we are talking about? Here, the requirements we are mentioning is the system requirements. Okay, what this system requires, or what the user requires.
Expectation.
Yeah, expectations. We're going to structure this somehow using some methods. we will try to structure it. But first, we need to understand the business itself. Okay, how the business works. What is the inputs and what are the inputs and what is the output? What are the outputs? What is the expectation? Again, for the system. If it is a warehouse, you need to name the expected outcome, or let's say a good working, perfectly working warehouse for that company. What is the output? What is the expectation? What is their expectation? So your system is expected or assumed to deliver or address somehow, maybe not completely, but at some certain point, some certain extent, you need to deliver or address all these needs, all right? So you need to understand the business itself. It involves in many different activities, surveys, interviews, all these type of activities. We're going to cover them next week. This week, I'm just trying to give you some feeling or understanding about the analysis stage. But before going to that point, let me go back to the initiation stage and talk a little bit about, or give you a reminder about initiation process jobs. We talked about the feasibility analysis. This is the most important or the main activity of the initiation stage, right? We said that every system is to answer some question. Therefore, every system starts with a complaint of any type. It may be a complaint of competition, maybe a complaint of some missing goods, or the goods that cannot be delivered in time, this type of stuff, right? Some complaints should occur or exist. Then we start thinking of developing a new system, right? Therefore, as I said, that we do some initial or preliminary analysis to understand it, and we need to develop a preliminary, primitive, prototype, let's say, system solution, right? And then we need to present them the solution and the cost, the timing, and everything. Okay. And at the end, what was the outcome of this initiation stage? The approval of the system, right? User approval. The user needs to approve the system. Okay. That means that they're going to decide about whether they're going to have it built or not. How they can decide about it? Of course, through the feasibility study. I gave you 4 main feasibility stages, steps. What was them? Remember, one was, what is it? Financial feasibility, right? Financial. And the other one was what? Technical feasibility, right? And what? Operational, right? Operational or organizational operation. And also, I don't know why, but the books, most of the books do not cover. I add this time or scheduling, timing, feasibility. Whether we can complete the system in time, right? They may have some time constraints. They may want the system to be delivered or deployed at the end of this year, for instance, some time limitation, some constraint. So they need to check with the timing you provide, okay? And we discussed all of these one by one. And during financial feasibility, I told you a couple of, I described a couple of concepts like break-even point, right? Break-even point. What was it? This was the cost of the system, and these are the incomes. And here is the the break-even point, right? And I also draw another thing. If this is the current cost and current income, so this is the profit, right? Here. But by the existence of the new system, cost will be dropped to that level, assume, and maybe the income will go increase to that level, some level. So this is the new cost, and this is the this is the new income, this is the new cost, Drop. So the new profit occurs here, right? This is the profit. So actually, this is the real income of the system or profit of the system, right? So this is the cost and this is the profit. Therefore, from this, we described another thing. What was it? Return on investment, right? Return on investment. I invest such a money and it just pays back from, starting from this point, it starts paying it back. So if we compute and accumulate all this money, we need to decide when will this return on investment will be covered or returned back, right? When the investment returns back, return investment. So besides this, there are some other things. For instance, there is another thing, net present value, we call it. The total cost of the system and total value of the system, added value. Okay, and they compare it. But of course, the added value or the cost are not that easy to describe or compute, right? Because, as I said, we are not talking about buying some printer or something. We're developing a system, so all the costs occur by the time, and it is somehow spread through time, right? At the beginning, we may buy some hardware and software, but here another part of software. Maybe here we just install or buy the networks, etc., right? So it doesn't occur right at the beginning, because here the initial cost, initial investments, right? But later there may be some other investments. So this curve wouldn't go this way. Of course, it may go this way and then here somehow. So at this stage, this is the operational cost. Only the operational cost involves, right? If this is the case, if this is the picture, how can I describe net present value? I can describe the total investment for this project, the total investment, the cost. It may be easier, but I cannot describe the value it added, right? Even the tangible value. You can measure some tangible values like the number of goods increased, the increase in the number of goods sold, let's say. It was, let's say, 5 in a month, now it is 6 in a month, or something like that. Okay, these are tangible, you can measure them. But even in this case, if it is that tangible and easy to compute, you still need to provide some time period, right? Time period. We're talking about the value of the system, the total value, added value of the new system. But in what period? If we're talking about a year or something, it changes, you see. But if we're talking about the return on investment time, I mean, we can say that it completely returns the invested money back when maybe 7 months later. Then we can measure this, okay? During that 7 months, how many, what is the, well, it is equal to return, I mean, the cost at the beginning of the investment itself, right? So this is one, but if we're talking about the net present value, we're talking about some other time, so we need to compute it by that time, according to that time, right? It is not that easy, but naturally, during the feasibility study, they just look at this break-even point and also the return on investment point, basically. Again, guys, also there are some other things, intangible gains from the system, etc., which is not that easy. But these are the decisions to be made by the user side and the user management, right? Whoever is authorized to make such a decision. Therefore, it's not your business. But since you are to deliver some system proposal, okay, some system proposal, you need to understand how they're going to look at this proposal and how they're going to compare the cost and investment and everything, gains and everything. All right, you need to understand it, but you are not the ones to compute all these things, return on investment, etc., etc. Because you cannot know their income completely or truly. You can just guess. Besides, you cannot know their operational costs. They may tell or may not tell you the cost. Right?
It can be higher than we expect or lower than we
Yeah,
expect.
lower than we expect. But at least we need to think about it and have an idea, a generic, broad idea about what may be the value for them. What may be the value of this new system or the new system. Okay. All right, guys. So, for instance, in the book, one of the books, I believe, there is another chapter devoted this stage, that part. What was it? Yes, systems analysis. I don't know, it may be here in this book. No, okay. Planning phase. Not in this one, maybe in the other one. So, let's remember again, what was the question that we need to answer at this stage? What was it?
Should we develop such
Should we develop? If we should, why? Right? So the main question is why? Why we should develop this? But here, what was it? What we're going to do? What is the system supposed to do? What is to deliver? Right? What is the goal? And here,
How?
yeah, how. And then here, we just do. So here in this, bunu açamadım ya. Açmış mı? Niye göremiyorum? Planning. Buraya bakalım. Mesela buna bakalım. Planning phase. Project selection and management. Here, for instance, in chapter 2, we covered this. Systems analyst and information system development, etc. Forget about it. All the feasibility study and everything, it's covered here. But here, they say that project selection and management. Well, it tells some of the details of user decision. I mean, how they're going to make this decision. But it is not necessary for you on your side. You need to understand they need to look all these stuff. But another thing, I again need to emphasize, what was it? You need to identify all alternative solutions, all right? And you need to conduct this feasibility analysis for all alternative solutions, not only one, but all. Then decide. Then decide and present them, okay? So this is the case. So I'm going to omit or skip over this project selection management. into the analysis phase. But here, right, in this intersection, after getting the approval right here, we need to, as the first activity of analysis stage, we need to establish the project team. All right, guys, team. So what is that? This is the very first step or activity of the analysis stage. We started with this, or we can say that from initiation, we just get into this stage after getting the approval. We just need to establish the project team. What is it? Well, the project team is this. Okay. The people or the team who builds that bridge, okay? It is very important how to, what are the considerations during establishing such a project team? What are the considerations? We're going to discuss them in the next week, okay? Let's stop this point. From this point on, we can continue next week. Okay, any questions?